Good morning to all of you. Last class we discussed about the thermocouple, purely thermocouple. Thermocouple. We discussed about the thermocouple. One person, that means thermocouple means here two dissimilar materials and joined together, and the two junctions maintained at two different temperature. One is a cold junction, another one is hot junction, otherwise temperature T1 and T2, thereby the EMF produced. Right? That effect is called, actually it is a Peltier effect. So here whereas Seebeck effect is uh, uh, the two joined is not maintaining at two different temperatures, then the potential difference is produced is called the Seebeck effect. Then the effect we can call it as a Seebeck effect. One person asked about the Thomson effect, right? So whether he came or not, I do not know. If he came means just you raise your hand. Just one person asked, sir, I did not discuss the Thomson effect. Now I am going to discussing about that one. Who? Lateral entry 30. You asked about Thomson effect. Yes. Yes, okay, okay. Here, Thomson effect, why I did not discuss means, why I am not interacted with the effect thermo Thomson. Because this is Seebeck and Peltier related to the thermocouple. Our topic is thermocouple. But here, this Thomson effect is actually the Thomson effect. That is in 1852, the William Thomson discovered this. Here in this, the electric current flows along a single conductor, only one single material. With temperature gradient, then maybe the power may be either absorbed or rejected. So here the development of power takes place in the Thomson effect. But the conductor is only single conductor. Here in our Seebeck and Peltier, here two dissimilar materials are two dissimilar conduction materials. But here only single conductor. That is the thing. So that's why I'm not discussing this one. Actually, the difference, major difference between the this Thomson and as well as Peltier and Seebeck is Peltier and Seebeck effect only in thermocouple. But that is in Thomson effect, just we have to deal on a single metallic rod or single conductor or single material, which is not in the thermocouple, which is not in the thermocouple, right? That is the thing. So, but why here I am not discussed the Thomson effect means here uh, reason. What is the reason? Here in our syllabus, the topic is thermocouple. In the thermocouple, only Seebeck effect and Peltier effect. But this Thomson effect, it does not coming under to the thermocouple. So here the maybe for a single conduction, here what happens means when the current flows along a single conductor with temperature gradient, then power may be either absorbed or rejected. That is depending upon the relative direction of the current and maybe the heat flow. This that effect is called Thomson effect. Now it is clear, Mr. Lateral 30. Now it is clear. Okay, okay, right, right. So that's why I'm not discussing that one. It is apart from the thermocouple, right? So now here the screen is visible to all of you. Screen is visible to all of you, thermistor and pyrometers. Screen is visible. Screen is visible. Thermistor and visible, amma visible. Kanabadutunda? Right. Very good. Thanks. Thank you. Thank you. Then uh, today we are going to go here. Today we are going to discussing the topic thermistor and pyrometer. So after completion of the class, we can get the knowledge on thermistor as well as pyrometers. Thermistor and also in the applications of thermistor, applications of pyrometer. What are the advantages of thermistor and pyrometers? So we can get knowledge on these topics after completion of this class. Now we are going to discussing about now thermistor. Here thermistor in the name itself only is there the thermistor. See here in the name itself only thermistor. Here see if you see therm and these two words, the combination of these two words. That means thermo means thermal or heat energy or the measurement or temperature. You can call it a temperature. ISTOR means it's nothing but a resistor. Thermal plus a resistor is nothing but thermistor. Thermal plus resistor is nothing but thermistor. Here, what is the function of the resistor? Anybody? What is the function of the resistor? What is the function of the resistor? Thermistor is nothing but the word THERM is nothing but thermal, and ISTOR is nothing but resistor. Thermal plus resistor is nothing but thermistor. It controls the electric supply, temperature resistant, resistance to flow of current. Right, all are right. So it controls the supply of current. Right. The resistor function is it opposes the flow of electrons, or in other words, it opposes the flow of current. That means it resists the flow of current. As one body says, all persons, whatever the written in the chat box is 100% right. So the function of the resistor, that is the function of the here with the help of the thermistor device or a sensor, so or an instrument, with the help of that instrument we can measure the temperature of the body of a particular body or a substance. So here in this if you observe clearly, see here a thermistor is a temperature sensitive resistor. See here it's clearly mentioned it's a resistor and it is a temperature, right? Thermistor is a temperature sensitive resistor. Why here? Here I will tell you why here we have to related the current, sorry, to thermal. Here when the flow of electrons takes place, then this resistor opposes the flow of electrons. Thereby, what happens means the heat develops, thermal energy develops. Here, this thermal energy, so maybe some heat develop, right? So that's why we can call it as a thermistor. So and then, unlike the metals, here this thermistor, it is having a specific function. See here, if you observe clearly, decreasing in resistance value with the increasing value of temperature. Here, see here, opposing. Here, the temperature value increases automatically in the thermistor. There will be a decrease in the resistance value. That means resistance value decreases means then it is actually it is inversely proportional to the temperature. That is the specific function in this thermistor. Decrease in the resistance value, there will be an increase in the value of temperature. So actually it is made up of some materials. What I said, all these sensors and transducers are made up of particularly with some materials. With the help of that materials only, it is having some specific function to work. So here in this thermistor, oxides of nickel, it is made up of oxides of nickel, oxides of cobalt, and oxides of manganese and sulfides. Oxides of here, oxides of nickel, cobalt, oxides of cobalt, and also oxides of manganese, and sulfides of iron, aluminum, or coppers. Sintered. So this is sintered metal oxide means the same coming under this nickel. So that means cobalt, iron, manganese, and nickel. Same. This is oxides of nickel, cobalt, and manganese, right? And doped and also doped polycrystalline ceramic. That means doped means impurity. Impurity polycrystalline ceramic. Ceramic, I think all of you know that pinganile. Doped polycrystalline ceramic containing barium titanate and other compounds. Here, see here, this, if you see, observe, this is a thermistor. Here, if you observe this thermistor, it's a very, very sensitive element. Temperature sensitive resistor. We can also call it as it is as a temperature sensitive resistor. Temperature sensitive resistor. And then here, this thermistor, it is having, it measures the temperature from minus value also, from minus values. That is a specific function, another specific function in this thermistor. One first specific function is when the temperature increases, there will be decrease in the resistance. And another one, it works, it also measures with the help of the thermistor, it also works in negative temperature. That means from minus 250 degrees centigrade, negative temperature coefficient. And also it measures the positive temperatures also. So these are the different materials used to prepare the thermistor. That means here the materials used in thermistors, if you observe clearly, materials used in thermistors for temperature measurements have a very high temperature coefficient. That means very high. Yeah, that means 8 to 10 times higher than that of the platinum and copper. And also higher resistivity. That means higher resistivity means it is having uh, to resist the flow of electrons very higher. Very, that is the meaning of higher resistivity. Higher resistivity means it resists the flow of current probably in high. And thus they are very sensitive. What I said, it's very sensitive. That means actually this thermistor, it works only in that particular range. If it exceeds, what happens means because it's a very sensitive element, the limitations should be like that, then automatically the thermistor fails to work. And small variations in that means small variations, there is a small variations in temperature, and it responds very quickly. That means it gives the output very fast. Once it is very sensitive for that means sensitive to smaller variations in temperature. That means small variations in temperature meaning means see here in the next sentence, the temperature range of a thermistor is minus 250 degrees centigrade to 650 degrees centigrade. That means it will works under that limit only. If it small variations in the temperature, it will not work because it's a very, very sensitive. It fails to work. And another one is advantage is it responds quickly. That means it gives the output very, very fast. There is no delay of time. And here thermistor are also produced. These are already I told to you the manganese, oxides of nickel, cobalt, nickel, copper, and iron, zinc also here. Here in the previous would not discuss it, zinc, iron, zinc alloy, and titanium and tin alloy. These are alloys. In the previous case, we not discussed the alloys. Here nickel, cobalt alloy, nickel, copper, iron, zinc, and titanium tin. So the materials, these are the materials used. That means to produce thermistor. Right. The thermistors, there are two types of thermistors here, depending upon the temperature coefficient of resistance. So one is what I said, it is a positive temperature coefficient and negative temperature coefficient. See here in the positive temperature coefficient, the resistance will increase. See, all of you note down this one. Here, the resistance will increase with increasing in temperature. That means here in the positive temperature coefficient, it is proportional. It's proportional. That means when the temperature increases, automatically the resistance, actually, that is actually all members known very well. If the temperature increases, automatically the resistance value increases. But in the negative temperature, here the temperature means here the temperature decreases. Are you understand? So when the temperature decreases, automatically the resistance increases. So that is reverse. The resistance will decrease with increasing in temperature. That means in the negative temperature, if the temperature increases, that means -5, -10, like that. In the negative temperature increases, then automatically the resistance will decrease. Obviously, ikkada koncham don't get confused. Here both are same. But here the function, why we can call it as a positive temperature coefficient and negative temperature coefficient. In positive temperature coefficient means, that means, for example, the temperature increases. That is 5, 10 degrees centigrade, 15 degrees centigrade, 20 degrees centigrade. Thereby, automatically the resistance also increases. Once the resistance increases, thereby thermal energy develops. Thereby, what happens? The temperature increases. But in the negative temperature coefficient, reverse. Here, if the resistance will decrease, there will be increase in the temperature. Here, increase in the temperature means what? -5 degrees centigrade in negative, -10 degrees centigrade, -15, -20, -30, -50, -100, up to what here the range up to -250 degrees centigrade. That increase here, the increasing in that is the increase here. So there will be once the negative temperature increases, there will be a decrease in the resistance, obviously. So now you got the correct one, right? The next applications of the thermistor. See here nowadays this thermistor can use even in advanced also. See here if you observe it here in this even it is used in 3D printers, hot ends, to monitor the temperatures of the hot ends of the 3D printers. And also see here in the it controls the operations of consumers applications, right? The consumer we get toasters, right? So bread toasters and coffee makers, refrigerators, freezers, hair dryers, etc. These are the completely in consumer applications. This thermistor. This is very small element. Maybe in our lab is also it is available. Of course, may I do not know. Okay. Thermocouple only it is available. Thermistor sensor is not available. It is used to monitor the coolant temperature or oil temperature inside the engine. So this thermistor, it is used to find out the coolant temperature inside the engine or oil temperature. To monitor the temperature of the incubator, that is another application. And thermistor are used in modern digital therm. That means regulator. Thermostats means, I think all of you know that thermostat means is a current regulator, regulating the current. So there the thermistors can be used, and it monitors the temperature of the battery packs while charging. While charging, it monitors the temperature. And even we are saying that -250 degrees centigrade. That means in the minus temperature we can call it as a cryogenics. Cryogenics. Negative temperatures, it's a very typical. Maybe it's sometimes it freeze like a snow, total completely the body, whatever may be the substance. So there we can store some of the material we can store. Uh, some of the material you can store in the negative temperatures, right? And also to maintain correct temperature in the food. So handling and processing industry. That means all you know very well in the cold storages. So there the temperature very very less in the cold storage. Even the bacteria will not affected on that food. So I think all of you know that there are so many food, the cold storages are there, right? In the cold storage, the temperature is very less. And to monitor that one also, we can use a thermistor, the temperature control to control the temperature. That means the food is not affected with the bacteria. And to maintain the correct temperature in the food. That means to maintain the correct temperature of food handling and processing industry equipments also. So industry, so here one operation to the other operation, the temperature may changes. So you can the processing industry equipments also with the help of the thermistor, we can control the or we can inspect the temperature correctly. Yeah, that means accurate without any deviations. These are the applications. Next, this is one of the bimetallic sensor. Uh, Bimetallic sensor. So here in this bimetallic sensor, actually it is not there in the syllabus. Just simply I am discussing. Here in the bimetallic sensors, here if you see two metals, metal A and metal B. Two metals are there, and these two metals having different materials. When it is exposed to the temperature, what happens, it will bends in this direction. So right, and here if you observe it here, it will the cantilever type metal, it's here it bends like this. And in the J shape, it will bends that means when it exposed to temperature, it changes its shape. See here in the spiral tube bimetal temper, that means the material when it is exposed to temperature, it elongates. See here it elongates. It is used in the application where in the iron boxes, right? In the iron boxes. Here, when the metal, initially the metal is at here, and similarly here also in the material is at here initially. So here, when the temperature increases, automatically the iron box shut off. That means if temperature increases, it elongates. So here, button is there. It will pushes that button automatically. The current shut offs. Thereby, the iron box is in off condition. So when again when it touches, this is a, for example, take example. This is the this is right. When it is exposed to the temperature, then automatically what happens, it elongates, and then when it touches, automatically the power cutoffs. And when the automatically when power cutoffs means automatically the temperature decreases. Once the temperature decreases means again this bimetallic tube will not in contact with the tube with this button. Then automatically again the current is in on condition. Here, if you observe it here, here in this case also, when uh, this elongates, this metal A and metal B elongates, automatically it bends, thereby it touches this button, automatically the power cutoffs. When the power cutoffs means automatically the temperature of the iron box decreases. Once it decreases means the contact between these two will be removed, and again the power will on. Thereby this happens in the iron box. That means automatically the current will on, automatically the current will cut off with the help of this bimetallic sensors. We can call this a magical materials, right? So here in this, the coefficient of metal A must be greater than the coefficient of the metal B. That means here it is written both are elongating the same. No, here both will not elongate. Here the material changes means automatically the thermal coefficient is also changes. Thereby the elongation is also changing. So now it is clear. So this is not there in the syllabus. Just I'm explaining. Next, pyrometers. Next, we come to the pyrometers. Pyrometers, right? In the pyrometer, if you observe, pyrometers means it is also a meter which is used to measure the temperature of a substance or a body. So now here in this case, the pyrometer temperature measurement is based on the change in the intensity of the color of radiations. That means here, for example, a light falls on this on my hand. One torch light falls on this my hand. One torchlight here, one torchlight light that radiation falls on my hand. What happens means, for example, 5 minutes, this body automatically, when the radiations falls, automatically this total hand, wherever that particular place the radiations it is incident on that my hand, then automatically what happens, the temperature will increases, the temperature differs, temperature changes. So here we have to measure the temperature with the help of the pyrometer. Here, for example, the tube light. See the tube light. The tube light, see here, it glows automatically. The radiations falls on some particular bodies. Then maybe the type of the objects also, if you measure the temperature changes. For example, take the sunlight. Here, if the radiation is there, then only you can see the object clearly. So we can also name it as the color also due to the intensity and intensity of light, and also there will be a change in the color also. That means, for example, take the black body. It absorbs the radiation much more compared to the white body. So here the black body absorbs the radiation faster. That means the temperature differs. If the color varies, the radiation absorbed also differs. If the radiation absorbed differs, then automatically the temperature varies. Remember this point. Here, the pyrometer is used. If you see here, the pyrometers are used in temperature measurement by radiations. Here, here radiation. Here, the radiation falls on your body. Thereby, what happens? There will be change in the resistance on that particular body. Once there will be change in the resistance, means there is a temperature variation. That temperature we can measure with the help of the pyrometers. And it is also possible to determine the temperature of a body through a measurement of thermal radiations emitted by the body, and also thermal radiations also. Thermal radiations mean here the radiations emitted by a body is very too hot. That radiations. I'm saying about that radiations, thermal radiations, the hot energy. See, for example, if your one heater is there, right? One heater too hot. When you place a needle to the heater, then automatically the thermal energy radiations. For example, if you see the engine, the bike. For example, the bike runs for a while of 1 hour or 2 hours. Then just you have to place. Don't touch on the engine. Just you have to place near to the engine some distance your hand. Then automatically from the engine, whatever the thermal radiations emitted, and it is absorbed your hand, and then you can say it is a very hot conditions. Even for example, in the household appliances, if you are cooking a water cooking a water, what happens, it reaches to the 100 degrees, then you place hand on that top, then automatically this thermal radiations are emitted by the body. We can also measure the thermal radiations emitted by the body, the temperature of the thermal radiations emitted by your body. It's not a radiations, it's a thermal energy. Thermal energy is transferring to the surroundings from a body. That is thermal radiations, right? Radiations. Maybe the radiations is very too hot sometimes. Thermal radiation, that means a light. For example, sodium vapor lamp, if you observe, there the heat is very more. The radiation is very more. So that's why it is somewhat we are placing some far distance, that radiation. And then here in this, there are three types of parameter: total radiation parameter, infrared parameter, and optical radiation parameter. Three. Now we will discuss one by one. Total radiation parameters. Here in this, you can observe about this total radiation parameter. Right. In this, if you observe total radiation parameter, again, total radiation parameter. See here, if you observe a furnace, it is a furnace or a hot body. It is a furnace or a hot body. Whose this is a furnace or a hot body whose temperature has to be measured. And see here that hot body or a furnace, it emits thermal radiation that it is focused on this lens. From that lens, it falls on the mirror. It falls on the mirror. It falls on the mirror, right? Here, this is a mirror. From the mirror, so some of the percentage of these radiations will falls. That means reflected on the another some lens here, and another with the help of the lens, it will these radiations will converge us at one point, and here at that point we are arranging a thermopile or a thermistor or some other sensor or a device which is used to measure the temperature. Here, the thermopile is nothing but it is one of the device like thermistor which is used to measure the temperature. Here, thermopile, in other words, we can also place here a thermistor. Here, see here from the furnace or a hot body, the thermal radiations are emitted and it is focused on the lens, and then the focusing the lens, and then it falls on the mirror, and some of the percentages of the that radiation will be reflected towards in this direction, and then it converges at one point. At that point, we have to arrange a thermistor or a thermopile device which is used to measure the temperature of the furnace or a hot body. And then see here some and the remaining percentage of the radiation it falls on the lens, and then with the help of the eyepiece, the observer can observe. He has to adjust such a way that the radiations will falls on the lens correctly. Here, why here eyepiece or observer means he has to adjust whatever the radiations from the furnace that falls on the lens correctly. He has to adjust, and once it is adjusted, then we have to measure the temperature of that particular hot body or furnace with the help of this thermistor device or a thermopile, and then it is displayed in the temperature display. It will indicate or we can record the temperature of the hot body or a furnace. Now you can get the clear idea, right? This total radiation pyrometer, total pyrometer radiation, right? Right. Then here, this is we can also this pyro radiation pyrometers. So mainly on that monochromatic source. 1 minute. 1 minute. Okay, right. All of you listen. Right. See here, this is radiation pyrometer. And the next we will discuss about the. That means here radiation pyrometer means the radiation emitted by an hot body. We have to measure that temperature of that hard body or a furnace with the help of this pyrometer that is arranged by a mirror and some lenses, and with the help of some temperature device. With the help of the device, we can measure the temperature of the hot body. What is clear? Are you understand? Any questions? Any questions? So advantages. Advantages. It is a non-contact type of. Yes, it is a non-contact type. That means from the hot body whose temperature has to be measured, this pyrometer you have to place some distance. It is a non-contact type of device and it gives a very quick response. It's a very, very quick response. The output of this one is very, very fast. And uh, see here, if you observe clearly, high temperature measurements can be applied. With the help of this one, we can also go for to measure very, very high temperatures. And disadvantages, errors, there will be error in the temperature measurements are possible due to emission of radiations to the atmosphere. That means some of the radiations will be exposed to the, that means it will be to the atmosphere or to the surroundings. There, some temperature measurement will not be accurate. We cannot get the correct value. Maybe some errors will take place in the measurement of temperature, and emissivity errors affect measurement. That means what are the emissivity errors? So maybe the emissivity differs from body to body temperature. Sometimes due to the time variations, that emissivity of radiation will also changes. That maybe affects on the measurement. That means maybe for half an hour the temperature maybe changes, small changes. That is the error. One person asked, maybe not used for cold substance. Yes, it's not used for cold substance. It's not used in a cold substance. So here in this, that is the, it is not used for cold substance. Here the cold substances will not emit the radiations. Only where we cannot measure the temperature, it's very too hot. At that particular places only this pyrometer will be preferable to work. For example, if you go to Vizag steel plant, there the temperature is very high. At that places, it's a very difficult to measure the temperature. With the help of this non-contact type of device, you can measure the temperature. Of course, maybe even though in a high temperature, for example, in the boilers, very, very high temperature, high pressure, there you can measure also with the help of some devices which we have to incorporate inside the device. Or sometimes we can go for these pyrometers, which is a non-contacting type device. The next, optical pyrometer. See here, this optical pyrometer, same as that of this one. Optical pyrometer, optical pyrometers. It is a monochromatic radiation. It is a monochromatic source. Sure, pyrometer. Yeah, okay, okay, right. I will explain the pyrometer working. Right. Again, I will work. I will explain all of you. Listen carefully. Here, see here, it is a this is a furnace or a hot body. This is a, for the black is color is a furnace or a hot body example. It emits radiation, and then we have to find out the that temperature of a hot body or the temperature of a furnace. And then this emits radiations. It will be focused on the lens correctly. For this focusing on the lens, we have to adjust with the help of this eyepiece set here. It is here observer is with the help of that observer, by making small adjustments, then total whatever the radiations emitted from the hard body will focus on the lens. And after the lens, and then it will be focused on the mirror. In the it will focus on the mirror. From the mirror, some of the percentage of the radiations will be reflected, and it converges. See here, it converges at one point, And at this point, we have to arrange a device called a thermopile or a thermistor whose temperature of a hot body has to measure. That means all the radiations will focus at one point. At one point means then automatically the temperature is more. For example, here, for example, see here the radiations like this, radiations like if the radiations will be like this means then the temperature we can't measure correctly. Our aim is all these radiations will have to focus on at one point. That means see for example see here radiations will focus at one point. all radiations will all the radiations will focus at one point. Example I'm saying. See here, all this focus, all the radius will meet at one point. Then automatically we can find the temperature of that emitted body. That is the radiations emitted body. So if it is like this means we cannot measure the temperature. So with the help of these arrangements, that means lens and mirror. Here, when the here we are arranging a mirror, with the help of the mirror, some of the that means the radiations is reflecting and it is focusing. That means almost all high percentage of radiation will focus at or it converges at one point, and then at that particular point we have to arrange a device whose temperature has to be measured. Then it will be displayed the temperature display, right? Here some of that radiations will goes to the eyepiece such that we have to adjust the all the radiations will focus on the lens. Now it is correct. His eyepiece is uses to adjusting the reflector to thermocouple. No, 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 no. Maybe here, the eyepiece. One person asked that 20. His eyepiece is used to adjusting for reflector to thermopile. Yes, maybe that is also. No, no. Actually, maybe that will not arrange. We have to maybe the focus at some particular distance. Here mainly this eyepiece here if you arrange that whatever the radiation will focus on the lens, that is main objective. Maybe this one also here it will we are not seeing this one. uh, all of you listen carefully, all of you listen, and this maybe with some distance. What you said, one number 20 Manikanta, uh, is eyepiece is uses to adjusting for reflector to thermopile. No, yes, yes, yes. That is also it is possible. We have to adjust such a way that firstly we have to maintain the distance correctly. If the distance is direction changes, then automatically, see here actually, I have to write the directions. All of you see here. So good question. Is number 20 Manikanta. See here, this is the focusing, right? All of you see here. Here, see, when it falls at here, it falls on the mirror. All of you observe clearly. Here, from this point to radius, that means it is one direction. And see here for this direction, this is another direction. Whatever, so 1 minute. Here some disturbance is coming on my monitor. This is the radiations, right? And here whatever the radiations falls at here, it will displace at here. It will reflect it and it converges at one point. And then here some of the one it will be falls and converges on lens. And from this lens, with the help of the eyepiece, you can observe it. Here the observation mainly on this focusing, and also maybe this whatever they reflected will converges at one point. And at this point, we have to arrange a device. Okay, na? Babu? So one person asked. lateral entry 38 and 20. So pyrometer working principle. That means it absorbs the radiations, and then all the radiations will be focused on one point. From that point, we can measure the temperature of a particular body. Number 20, Manikanta. 20, Manikanta. Leda unnada leda ఆయన? Number 38, lateral entry. Number 38, lateral entry. 38. ఆయన అడిగాడు once again explain pyrometer working. And చెప్పేసి వెళ్ళిపోయాడా? ఉన్నాడా? Okay. Here, working principle is whatever the emitted radiations from a hot body or a furnace, with the help of some arrangements, we have to focus or we have to meet at one point. From that point, with the help of some temperature device, we have to measure the temperature of a hot body. That is the actual working principle. Okay, right, the time is over. Tomorrow we will discuss about optical pyrometer and okay, now I will take the attendance. All of you respond one by one. The chat box. So number 18th batch 320. Right, and 81, 18th batch 81. Right, 1, 2, 3, 5, 6, 7, 6, 7. 1, 3 option, 6, 7 option, 6, 7. 8, okay, present 9, 10, 11, 12, 11 option, 12, 13, 14, 15, 16, 17, 17, 18, 19, 20, 21, 21, 22, 22, 22, 23, 24, 25, 26, 27, 28, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 43, all right, 44, 44, 45, 45, right, 46, 47, 47 option, right, 47 option, 47 present, 48, 49, 49, 50, 51, 50 option, 50, okay, 48, right, 48 option, 51, 52, right, 52, 52, 52, 53, 54, 55, 56, 56, 57, 58, 59, 57, 58, 59, 60, right, 61. Lateral entry 1, 1, lateral entry 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17, 16, 17, 18, 19, 20, 21, 22, 22, 22, 33, 20, 20 to 23, 24, 25, 26, 27, 28, 29, 29. All right, 28, 28 all 28. Okay, 28 option, lateral 28 option. 30, 31, 32, 33, 20, right, 31, 33, 33, 34, 35, 34, 35, 36, 37, 37, 38, 39, 40, 41, 42, right, 42, 43, 44, 44, 45, 46, 47, 47, 48, 49, 50, 51, 52, 51, 52, right, 53, 50, 53, lateral entry 53, 54, 54, lateral entry 54, 54 option Tamma, 55, 55, 19th batch 53, present, okay. 56, okay, 55 option Tamma, lateral 55 option, present 55 present, and 54 option Tamma, lateral 54 option, 56 present, 56, 57, 56, 57, 56, 57, 56 Nana, 54 option. Here I am reading the absentees. All of you listen carefully. Here the regular 1, 3, 6, 7, 11, 17, 18, 19, 21, 17 present. 17, 17 present, 18, 19, 21, 22, 48, 52. Absent. Regular. Lateral entry 36 lateral. 36 regular present amma. 36 regular present. 58 present. And lateral entry 24 is also present. 22 is also present. Great. Again, I am reading all of you see here. చూడండి ఒకసారి వినండి. And regular 1, 3, 6, 7, 11, 18, 19, 21, 22, 48, 22 present, 22, 48, 52 present, 22 present. Okay, right. And the next lateral entry 54, 56, 57. 54, 56, 57. 19th batch 303 present. And the lateral entry 54, 56, 57 absent. 54, 56 only section B, 56 present, lateral 56 present. Okay, 54 would present. Okay, 57, 57 absent lateral. Okay, only in section B, only one person option 57, and the regular 1, 6, 7, 11, 18, 19, 21, 48, 52 option. ఎవరమ్మా lateral entry 30, 31 option, okay, regular 11 option present. Okay, thank you all of you.